Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Identify the two olefinic, alkene, bonds in the starting material. 1. The endocyclic double bond in the cyclohexene ring, which is conjugated with the aldehyde, ChO group, making it an alpha-beta unsaturated aldehyde, enal. 2. The exocyclic isopropanol double bond, CH2 is equal to C, CH3, at C4, which is a simple, isolated terminal alkene. Moving on to the next step. Determine which double bond reacts preferentially with HBr, a mineral acid. Electrophilic addition. The problem states addition of a mineral acid to an olefin bond. The endocyclic double bond is conjugated with the electron-withdrawing ChO group, alpha-beta unsaturated system, making it less electron-rich and less reactive toward electrophilic addition. The isolated exocyclic isopropanol double bond, CH2 is equal to C, CH3, is more electron-rich and more reactive toward electrophilic addition with HBr. Moving on to the next step. Apply Markovnikov's rule to the isopropanol group. CH2 is equal to C, CH3, H plus adds to the terminal CH2 is equal to less substituted carbon, and Br adds to the internal carbon bearing the methyl group, more substituted, giving tertiary carbocation intermediate. This gives C, CH3, to Br, a tertiary bromide, at C4. And for the final step, the ring double bond, conjugated with ChO, remains intact because it is deactivated by the electron-withdrawing aldehyde and the isolated alkene reacts preferentially. The cyclohexene ring double bond still present, with ChO, and the isopropanol group converted to C, CH3, to Br. This matches option C. A cyclohexene ring bearing ChO, with C, CH3, to Br at C4. A. Places Br on the ring adjacent to ChO, wrong regiochemistry and wrong double bond selectivity. B. Reacts the ring double bond and gives secondary bromide from isopropanol, violates both selectivity and Markovnikov. D. Reacts the ring double bond and leaves isopropanol intact, wrong double bond selectivity. Therefore, the correct answer is C. Therefore, the correct answer is option C.